In this lesson, we are focusing on tangent inverse. And before we get into that, we're going to go back to the first two trig ratios that we've talked about just to review. There's sine inverse, which is used to find the angle x, which is equal to the sine inverse of opposite over hypotenuse. Cosine inverse is used to find the missing angle x, which is equal to the cosine inverse of the adjacent over the hypotenuse. And finally today, our focus is on tangent. And when we have a missing angle x, we can use tangent inverse of opposite over adjacent to find that missing angle. So using the tangent inverse ratio, we're going to find the tangent of x in order to find the missing angle x. To set up this ratio, we're going to need the opposite side, which is b, and the adjacent side, a. We know that c is not the adjacent side because c is directly across from the 90-degree angle, making it the hypotenuse. So the tangent of x, opposite over adjacent, is b over a. Now to solve for x and get it by itself, we have to remove the tangent, meaning that we're going to remove it from here, apply it on the right side as tangent inverse. So x degrees is equal to tangent inverse of b over a. If we wanted to find the missing angle y, we would start with that angle, look at the opposite, which is a, and the adjacent side, which would be b. So the tangent ratio of y, opposite over adjacent, is a over b. If we wanted to get y by itself and solve for that angle, we would need to remove the tangent by moving it to the other side and applying it as the tangent inverse. So y degrees is equal to the tangent inverse of a over b. In example 1, we're going to calculate the measure of the angle, rounding to the nearest tenth. We also need to make sure that our calculator is in degree mode. To find the measure of angle W, when the tangent of W is 19.0811, we need to apply tangent inverse to that decimal number. That leaves us with W equals tangent inverse of 19.0811. So we'll use functions, tangent inverse of 19.0811, giving us the angle W equaling 86.99. Now I've started with the rounding to the 2 decimal places because we want to round to the nearest tenth, meaning 1 decimal place. That first decimal place depends on the number behind it. The 9 in the second decimal place is going to bump the 9 in the first decimal place up to a 10. Well, we can't write a 10 in 1 decimal place, so that 9 transfers over to the next number, 6. So the angle W, if we're rounding to the nearest tenth, is going to be 87.0 degrees. Now, using an actual triangle, we will set up the tangent inverse in order to solve for a missing angle. So we're going to call that angle x and set up the opposite over adjacent. So the tangent of x is equal to 27 over 38. Now we're going to apply tangent inverse to that ratio, leaving us with x equals tan inverse 27 over 38. That gives us 35.39. If we're rounding to the nearest tenth, the 9 is going to bump that 0.3 up to a 0.4. Example 3, we have our missing angle x, we have the opposite side and the adjacent side. So the tangent of x is 9 over 21, and angle x is equal to the tangent inverse of 9 over 21. That gives us 23.19. Rounding to the nearest tenth, that gives us 23.2 degrees. In number 4, we have all three angles, but we're told to use tangent inverse. So directly across from angle x is the opposite side. The adjacent side is the one that connects to angle x, but is not the hypotenuse. So here we can see the 90-degree angle, and directly across from that would be the hypotenuse, which is 50. For tangent, we just need opposite over adjacent. So the tangent of x is equal to 14 over 48. So x equals the tan inverse of 14 over 48. That gives us 16.26. Rounding to the nearest tenth, that would be 16.3 degrees. And finally, example 5. We have our missing angle x. We're told to use tangent, so we need the opposite side over the adjacent side. Again, I know that from the 90-degree angle directly across gives me the hypotenuse, and we don't need the hypotenuse for a tangent ratio. So tangent of x is 68 over 51. So x equals tan inverse of 68 over 51. And let's see what tan inverse of 68 over 51 equals. That's 53.13. Rounding to the nearest tenth, that would be just 53.1 degrees.